This is TechKnow, a show about innovations that can change lives.
The science of fighting a wildfire.
We're going to explore the intersection of hardware and humanity, and we're doing it in a unique way. This is a show about science
Oh my God.
by scientists.
That's huge.
Tonight, TechKnow investigates extreme weather.
Flash flood warning for northwestern Los Angeles.
Dr. Shini Samara is a mechanical engineer. Tonight, she's in the line of fire.
I'm standing in what's considered to be a tropical windstorm at 45 miles per hour.
Marita Davison is a biologist specializing in ecology and evolution.
We're in the hydraulics lab at Scripps, where they've literally brought the ocean inside.
Stormy weather is causing devastation around the world. Coincidence or climate change? What's really going on?
Is what happened in Buffalo unusual, or is this the sign of things to come?
Now, leading climate scientists weigh in.
What impact does temperature and number of particles have on the production of aerosols and how that impacts seeding of clouds?
Can we weather the extremes? I'm Phil Torres. I'm an entomologist.
Weather is the shirt that you put on today, but climate is your whole wardrobe. Today, we're breaking out the rain slickers.
That's our team. Now let's do some science.
Hey guys, welcome to TechKnow. I'm Phil Torres, joined by Marita Davison and Dr. Shini Samara. With global climate change, we are seeing extremes. We are seeing the hot get hotter, the cold get colder, and it's hitting all corners of the U.S.
And what it means in the scientific community is that it's a really challenging time right now. Challenging and exciting to try to understand what these extreme weather patterns mean for our climate.
And I got to look at the significant costs involved with not just the devastation caused by extreme weather, but hidden costs as well.
And whether it's rain, heat, drought, it's happening, it's big. Let's take a look.
Oxnard, California, December 12th, 2014.
Roger, you have a flash flood warning for northwestern Los Angeles, in effect that looks like till 11:15.
The National Weather Service severe weather team has been at it for hours.
Not good.
I'll draft up a warning for that area.
The storm was no surprise. Scientists and TechKnow's cameras were tracking it. What meteorologists were calling the storm of the decade hit California with a vengeance.
I'm at the National Weather Service office. Operations here were at an elevated level in response to one of the worst winter storms to hit the state in a very long time.
9 inches at once reported in Napa Valley. Massive snow and winds in Lake Tahoe. Flooding rain in Los Angeles.
They're expecting anywhere between 6 and 8 inches of rain today, and the Russian River is going nuts right now.
This is a chance for scientists to study in real time the latest in a year of extreme weather events.
This storm was up there with the storm of the decade classification. It was a very intense rainfall over a short period of time with really strong winds.
John Dumas is the Science and Operations Officer at Los Angeles County's National Weather Service.
Can you talk a little bit about these extreme weather events and their relationship to climate change?
Weather is the shirt that you put on today, but climate is your whole wardrobe. Today, we're breaking out the rain slickers.
Severe weather events around the world range in extremes from devastating floods in Bosnia to record snowfall in northern Japan, and from widespread drought to record lake-effect snow in the United States. TechKnow's Shini Samara picks up the story.
Simply, all you need is cold air and warm water.
November 17th, 2014. In a video that went viral. This time-lapse shows the impact of lake-effect snow as it moved into Buffalo, New York.
People were stranded on the highways, the interstates, and whatnot.
Nicholas Metz is a professor of geoscience at Hobart and William Smith Colleges in Geneva, New York.
The way I tell my students to imagine this is imagine a ball at the top of a mountain. Just a little push, and that ball goes all the way down to the bottom of the mountain. Well, this is just the mountain flipped upside down, Just a little push and that air rises vigorously into the atmosphere and it produces these really, really intense lake effect snow bands.
It really feels like weather is becoming extreme.
A lot of the research has shown that, as our globe starts to change, extremes may become the norm.
So does science suggest that this is going to happen more and more?
I think that that's a reasonable inference to make from what we're seeing.
But when is extreme weather, like buffaloes, due to climate change? And when is it just plain wild weather? There's a new and growing scientific field called attribution science that tries to assess whether climate change played a role in causing these extreme weather events. Take the extreme heat fueling wildfires in Australia since 2013. Is it climate change? According to the research published in the Bulletin of the American Meteorological Society, probably yes. And what about the torrential rains that hit the United Kingdom in the winter of 2014? Climate change or just wild weather? A study out of Oxford University found that that event was probably climate change. California suffered through 3 years of debilitating drought. Is climate change to blame? Probably not. According to NOAA, California's drought, while extreme, is not an uncommon occurrence for the state. Natural weather trends are the primary factors. Still, extremes are in fact becoming the norm. 2014 will go down as the warmest year ever recorded worldwide. For climate scientists, understanding why is evolving with every event. California's storm of the decade may in fact be tied to a recently observed phenomenon known as atmospheric rivers.
Atmospheric rivers are here to stay. Well, really, it's a region of the atmosphere that's chock full of water vapor and has strong winds. It's carrying the equivalent of 10 times as much liquid as the Mississippi River.
Marty Ralph is an atmospheric scientist at Scripps Institution of Oceanography at UC San Diego.
It seems to be a very severe weather phenomenon.
Well, there's a lot to learn in terms of how atmospheric rivers behave and how dust particles can impact precipitation in clouds over the ocean and over land.
Along the coast in San Diego, Marita Davison got a lesson on how particles in the ocean interact with clouds and may hold the key to the climate puzzle.
When we see the dust or biological material that's potentially coming from the ocean, when we see that present in the clouds, we see lots of snowfall at the ground.
Dr. Kimberly Prather is an atmospheric chemist at Scripps Institution of Oceanography. Prather leads a team of researchers who are investigating how particles like dust and sea spray influence weather patterns.
So is what you're saying, in effect, that aerosols can impact some of the extreme weather patterns that we're starting to see?
The way you could potentially explain some cases of drought is, let's say, for example, you're in a polluted urban region. So things like soot and smoke definitely can reduce the amount of rainfall that comes out of that cloud.
Understanding how these particles play a role in whether a cloud will produce rain or snow is an important breakthrough.
The scientists trying to understand the science as fast as we can, but the choices that humans make are going to be the thing that determines how fast we can fix this problem.
We're talking extreme weather events, and over this last year, we've seen some big ones.
The scientific community is tackling this head-on, but there are a lot of economic consequences as well. And let's face it, when money's involved, eyebrows raise.
Yeah, and recently NOAA published some results saying that there were 8 specific weather events that cost over $1 billion. And I went to a lab where they can actually simulate that kind of devastation. Let's take a look.
In a concrete chamber, 7 stories tall and big enough to hold 9 football fields, they're making some of the most violent weather in America.
Tell me about this space.
This is a unique facility. We call it Mother Nature in a Box. We are really focused on extreme weather events, wind, water, fire, and hail.
And it's all powered by this colossal wall of fans.
Increasing wind speeds.
I'm standing in what's considered to be a tropical windstorm at 45 miles per hour. And that's a breeze compared to a Category 1 hurricane, where winds reach speeds of 70 miles per hour. And here, a wall of fans can generate winds of 130 miles per hour. That's enough to blow down a house.
What we do here is building by building combat.
Julie Roachman is the CEO of the Insurance Institute for Business and Home Safety, an industry-funded non-profit that recreates extreme weather conditions. With the escalating number of severe events, their goal is to change the way the industry builds and how codes are written and enforced.
Our research is geared toward identifying workable, practical solutions for builders, insurers, public policymakers. We want to show people how to design, build, repair, replace property better, safer, and stronger against the worst Mother Nature has to offer.
There's been a lot of political debate over climate change, what causes it, and its link to extreme weather. And insurers often have to foot the bill. Where does that leave you?
We've seen about $356 billion of insured losses from natural disasters between about 2002 and 2013. We do know that storms are getting more intense in some places. We also know that people continue to move to vulnerable areas.
Over the past decade, the priciest extreme weather events for insurers, hurricanes at $204 billion, followed by severe thunderstorms, heat and drought, severe winter weather, wildfires, and flash floods. The costliest in recent US history, 2005's Hurricane Katrina, with $149 billion in losses.
This one is rather unprecedented because it's being steered back towards the U.S. coast.
In second place, 2012's Superstorm Sandy, that tore through the Northeast with a $66 billion price tag.
That's huge!
Sandy and Katrina are part of a disturbing trend. A recent report based on US government statistics calculated that billion-dollar-plus weather disasters are growing by 5% a year. And on the steepest upswing, severe storms, often punctuated by shattering hailstorms, up to 3,000 a year now, costing $1 billion annually.
When you think of really destructive weather, your mind doesn't jump to hail.
Hail is something that is always around.
Tanya Brown heads the hail engineering team that designed the world's first indoor hailstorm.
We may not have huge fires, huge hurricanes, things like that, but we have hail every single year.
What do you use to simulate hail?
We use water with a mixture of seltzer sometimes, or we use the crushed ice, and we basically create spheres and create ice stones that we can shoot with our cannons.
And what kind of speed are they falling at?
Something like this would be 70, 75 miles an hour or so.
Oh,
yeah,
that's fast.
It is. They can cause a lot of damage, especially if you have a lot of these guys on your house.
On the other side of the spectrum, wildfire. 2014 was a brutal season, fueled by one of the worst droughts on record in the West and Southwest. It's a major concern for the insurance industry because 1 out of every 3 homes is now built close enough to be devoured by flames.
We're looking at the embers that travel maybe a mile or more beyond the perimeter of the fire and land someplace where there is nobody watching, and then there's flame generation, flame contact, and structures are lost.
Testing reveals some simple solutions: more fire-retardant building materials and fewer openings for embers to fly in.
Some of the research you've already conducted shows that, just tiny little design tweaks can really alter the outcome of how a structure survives severe weather.
I have here in my pocket something these are called ring shank nails, and you feel there are ridges down here. So they're different than smooth nails or staples, only in that there are those ridges that will bite into the wood. If you were to change on a house, just from smooth nails or staples to ring shank nails, you are doubling the strength of the connections you were already going to make for about $70 to maybe $100. That's a huge difference for not a lot of cost. If we just got the roofs right in this country, just the roofs, we estimate we could save about half of all insured property losses in a given year. That would be billions of dollars in savings for hundreds of dollars of investment per house.
Do you think weather could become more extreme?
I think with every passing year, Mother Nature hands us another large data point. So every data point that we get points us toward a different trend and a different definition of extreme. That's what we want to be prepared for.
Guys, we're talking extreme weather here, and I think we all know it goes beyond that 5-day forecast we're all used to. It's very complex trying to get a grasp of how the weather works.
Yeah, it seems to be that the more research we do, the more complex it seems to be.
Well, and we've made a lot of progress in understanding how weather patterns work, but we really are just scratching the surface in terms of understanding mechanisms for weather patterns and global climate patterns, for that matter. I got to visit a team of scientists at the Scripps Institution of Oceanography, and they're taking a look at how the ocean is driving weather and potentially climate. Let's check it out.
Observed integrated water vapors over land in this part of California. Then we have a classic atmospheric river located from southwest to northeast over the eastern Pacific Ocean, with generally integrated water vapors anywhere between 3 and 4 centimeters along the corridor, making landfall right in the Bay Area of California.
December 11th, 2014. Watching in real time as a massive storm hits California.
So there's sort of an atmospheric river extreme event focus. We were trying to actually see how different sources of particles actually seeded the clouds and affected whether they rained or snowed or sat there.
Climate scientists at Scripps Institution of Oceanography are investigating something that's tiny, but a huge part of the climate puzzle.
The single largest uncertainty in all of climate change is how aerosols form clouds and interact in clouds. The study that we're doing, we will be able to fly out over the ocean and see where these things are mixing and how this is ending up leading to more precipitation over California.
We're in the wet lab. We're preparing for a field study. What we're doing right now is cleaning a bunch of vials for our precipitation sampler, which we'll use to collect rain samples and use those samples to determine what seeded the clouds that made that rain.
Cloud seeding is where we intentionally, as humans, go and try and modify the properties of a cloud, usually with the hopes of getting more water to come out of that cloud.
La Jolla, California is home to Scripps Institution of Oceanography. Scientists here have been studying the ocean for over 100 years to learn more about some of the most complex issues impacting the environment.
The ocean blankets 71% of our Earth, right? It's responsible for a huge amount of clouds, and so the ocean serves as a very important source.
Atmospheric chemist Dr. Kimberly Prather and her team are tackling these complex issues head on.
Aerosol particles are these complicated chemical mixtures of everything, millions to billions of different compounds.
Figuring out how the chemistry of what lies on the ocean's surface has an impact on cloud formation and weather are two of the most challenging environmental unknowns.
It's a laser that's actually blowing apart the particle. So each time this comes down, that's a fingerprint of another particle. And we can say like car, that's dust, that's sea spray.
Sea spray is one of many aerosols that researchers at Scripps are studying. The aerosols float into the atmosphere in the mist we see when waves crash along the shore.
When I hear aerosol, I think of the spray can type.
You and everybody else.
But that's not what you're studying.
The aerosols we're talking about are aerosols that are produced naturally, so things like sea spray. That sort of myriad of interactions that leads to our myriad of different chemicals that are produced in the seawater, different types of bacteria and microorganisms that when the waves break, those can be lofted into the air.
Everything you've been talking about is highly complex.
The chemistry of what's in the seawater and then what actually makes it out, that's what's important to the clouds and climate. Some aerosols warm the planet, some aerosols cool the planet.
Recognized by the National Science Foundation, Dr. Prather led a team of researchers at the Center for Aerosol Impact on Climate and the Environment. They were the first to develop new ways of looking at the problem.
As we improve our models of climate, we can improve our understanding of whether or not we're more or less likely to get extreme weather. Every 20 minutes, those pumps turn on and they pump a large volume of water out of the ocean, and we have our own piece of it right here.
We're in the hydraulics lab at Scripps, where they've literally brought the ocean inside. As you can see, this 44-meter flume mimics the way waves break and produce sea spray to help us better understand how the ocean influences our climate.
We go out to sea in storms, and we measure the properties of the waves there, and then we measure the properties of the waves here, and we make sure that they're the same.
The 44-meter flume holds 56,000 gallons of water pumped in from the Pacific. A hydraulic paddle sends waves down the flume where they hit a board and crash.
We do the best job we can at reproducing all the complexity.
Oceanographer Grant Dean oversees operations in the wave flume lab.
You're focusing primarily on this very thin little layer at the surface.
The interface between the air and the water. And there's a lot of special chemistry that goes on there as well.
And since the ocean is 71% of the Earth's surface, sea spray is one of the largest sources of aerosols covering the globe.
Aerosols are made by foam that is made by bubbles. And we have measured the bubbles here to reproduce that natural process.
Catherine Moore is a staff research associate at UCSD and Scripps.
Here we're working on an electrolysis experiment where we're trying to generate bubbles of a known size, and we can get a full aerosol size distribution out of that bubble jet. We collect all the bubbles that come up from the surface, and as they make sea spray aerosol, we sample them out of this tube here. In the open ocean, we have a range of temperatures from the Arctic and the Antarctic all the way to the tropical Pacific or Atlantic. And so if the temperature matters, then we're going to change the cloud seeding properties, and so that has an effect on our global weather patterns.
In the Wave Lab, Grant Dean's hope is that data from these tank experiments will improve weather models to deal with problems ranging from drought to severe storms.
Take the results that we learn here so that we can do a better job of predicting weather and climate. Climate and weather are not the same thing. Weather is what we get on a day-to-day basis. Climate is what we experience over a decade.
Now, if we can sort of fly through and directly determine, which aerosols are making the clouds, what makes a cloud, and really improve the model treatment, and be able to predict where the clouds are, this will be a huge, huge effect on our ability to really understand what temperatures we're going to be facing in the future.
When we exploit the Earth, we have such little awareness of what type of impact we're having. How little do we know?
Well, if you think about it, we're just discovering that that top millimeter of the ocean surface potentially is driving a huge part of our weather system.
That seems to be an incredible new way of looking at this planet.
It blew my mind. I'm a biologist, so I should know these things, but it really completely blew my mind to think of all those microorganisms producing these tiny particles that are seeding clouds that are driving weather and, in a broader scale, driving climate.
Does that mean that everything we've ever studied and researched and concluded is now kind of invalid?
No. What we need to look at is this is another piece in the puzzle, another piece of information that we can insert, that we can use in climate modeling to help us understand how this very complex, dynamic system works.
They say you can't control the weather, but with all we've learned today, we're definitely getting closer at understanding how to predict it and certainly how to deal with its impact. But absolutely, just now scratching the surface. That's it for this episode of TechKnow. Be sure to check us out next time as we bring you more science and innovations from the field.
Dive deep into these stories and go behind the scenes at aljazeera.com/techknow. Follow our expert contributors on Twitter, Facebook, Instagram, Google+, and more.